This is my reassessment for chapter 14. I have a neutral atom and a point charge. This point charge causes an electric field on the neutral atom. The atom is now polarized with dipole moment. P equals alpha times E1. So this is the induced dipole now here. And so that causes an electric field, E2, on the point charge here. So the polarized atom now has a dipole moment of P equals Q2 times S. And this would be Q2 here. This is Q1. So I can find the magnitude of E2, which this is E2, so we're finding the magnitude of this, which is just E2, which is 1 over 4 pi epsilon naught times 2p over r cubed. And we know that P is alpha times E1, which we know from up here. So we just plug that in here, alpha times E1 over r cubed. And we also know E1 because that's just the electric field from a point charge. So we can rewrite that here and write that out here. This is the electric field of a point charge. So we combine that, and we get 1 over 4 pi epsilon naught squared times 2 alpha Q1 over r to the 5th power. So here I've drawn it all out. This is the induced dipole now of the neutral atom. This is the positive point charge. You can see here that the force on Q1 and the force on the atom are equal and opposite in magnitude and direction. However, the electric field here, E2, on the point charge, is much smaller than E1, the electric field, due to the induced dipole. However, they're in the same direction because the positive here is attracted to the negative here. However, the positive here is repelled away from the positive here. So now we can find the force exerted on the point charge, because F1 equals Q1 times E2. So we have Q1 times 1 over 4 pi epsilon naught squared times 2 alpha times Q1 over r to the 5th power times r hat, because that's the electric field, E2, that we found just a minute ago. And so we combine Q1 here with Q1 here, and we get Q1 squared. And we know that from Newton's third law, F2 is just going to be equal to the negative of F1. So that's the force exerted on the neutral atom, just the negative of this up here.